next speaker is Margit from Tartu Observatory, and as our most of our other presentations today are more into describing already working usage stories, but the presentation of Margit is somewhat different because the Sentinel 5B data about air quality and constituents of the atmosphere, it is quite new data flow as in Europe, as in Estonia, but I hope the presentation of Margit will open us the possibilities of measurement of the air quality. Please, Margit.
Thank you. I will. Okay. So thank you very much. I hope you can see my screen.
Yes, your slide is visible.
Okay, good. So as Martin also already said, I will be talking about remote sensing of the atmosphere and especially the atmospheric composition. And as this part is not yet involved in ESTHub, I'm not the user of ESTHub yet. So I will just introduce what is available in Copernicus program, what is coming, and how this data has been used and could be used. So currently, there is only one atmospheric composition mission in the Copernicus program. This is called Sentinel 5B. And this is a separate satellite that was launched just for these purposes. The launch was in 2017, and the satellite carries one main instrument called Dropbomy, which is a hyperspectral push-broom imaging spectrometer, and it measures in a wide range of wavelength bands. It is near polar orbiting satellite that is sun synchronous, so we get the information once a day for each location at the same time. And the spatial resolution of this mission is 5.5 times 3.5 kilometers. And the designed lifetime is 7 years, and we are almost at the end of the 5th year by now. The main data products that are measured from this satellite are ozone, NO2, SO2, CO, formaldehyde, methane, cloud, aerosol products, and surface UV. The surface UV products, there are over 30 different products that are available, but it is in different color because these products are not produced together with all the other products. The surface UV products are produced by Finnish Meteorological Institute, and currently the access is also through them and not through the Copernicus hub. And all those products are available near real time. So this is up to 3 hours from the measurements. And also offline products are produced, and these are available up to 2 weeks from measurements, but actually it's more like 1 day or even 12 hours, but the time depends on the product. So there are 3 main environmental themes for this mission. First of all, I think one of the main ones is air quality monitoring. So this is the measurement of all the products mentioned. Then this is global monitoring of the constituents that are relevant to climate forcing. And finally, monitoring ozone and UV radiation. And this data that is acquired is used in operational weather forecasts. and also in CAMS. CAMS is Copernicus Atmospheric Monitoring Service. So some of the data goes to there. And also data of SO2 is provided to Volcanic Ash Advisory Center to monitor volcanic activity. And based on this Sentinel 5B data, it is possible to determine sources and sinks of atmospheric pollutants, and also to provide information on air quality, to provide alerts in case there are some severe issues with air quality. So there are different applications regarding these health issues. So I will show some specific examples that have been done and can be done. First of all, currently, the data is accessible through Copernicus Open Access Hub, like all the other Copernicus data. And as I said, the UV data is available through Finnish agencies. So Finnish Data Hub system, or FinHub, is the access point for this UV data. And to everybody, this data is freely available. You just have to register in both cases, for Copernicus and for FinHub. And I hope in the future, this atmospheric data will be also available in ESTHub. So as I already said, some of the data is used in CAMS and is available through Atmosphere Data Store. Currently, ozone data is fully integrated into this CAMS system. Then NO2, SO2, CO, and formaldehyde are tested so that they could be included fully in this global real-time forecast system. And the next product that will be tried and tested will be methane. And again, this SO2 is used for volcanic activity. As the main goal of this mission is to monitor air quality, then there is a lot of different maps produced based on the Sentinel 5B data that you can find, and you can monitor the air quality. So on the left side, there is a map of 14-day average NO2 concentrations over Europe, and the darker the area, the more pollution there is. On the right side, this is a page from or image from Finnish example of these maps. So they have produced NO2 and also CO maps from the most polluted areas in Finland. And beside mapping the NO2 concentrations, they also use NO2 for reporting. For example, there are some companies that use this data to report air quality changes. I've seen a presentation, for example, regarding Neste. And also the Finnish government uses NO2 data as a part of this national air quality assessment that is then forwarded to European Union. So there is really official application on this data. Beside that, Sentinel 5B data has been used widely on different research. Here we have some examples of the studies on COVID effect on air pollution. This example is from China, and NO2 changes or concentration changes in NO2. So on the left side, this is February 2019, air pollution before COVID. In the middle, this is February 2020 during the lockdowns. And on the right side, this is February 2021, after the economy started up again. So you can see there is a real difference. And during the lockdowns, the air pollution went down. So this can be done with Sentinel 5B data. Here is a similar example from India and SO2, again on the left side, before COVID time. And then on the right side, April 2020, during the lockdowns. And you can also see this decrease in air pollution. Another example of how this data has been used is monitoring the emissions of NO2 from individual ships. Thanks to the good resolution of Sentinel 5B, it is first time possible to see these individual ship emission lines. So these are these dark red lines across the Mediterranean Sea. Each of these lines is from a single ship. Another example is detection of individual methane plumes leaking from natural gas pipelines. These images are from Kazakhstan, and the study was done from Kazakhstan. On the left side, image from Sentinel 5B, and on the right side, image from Sentinel 2. So there was a methane leakage, and this yellow line is the methane track. Then regarding these health issues, there has been a large number of different applications that partly use the Sentinel 5B data together with other data sources and models that provide this kind of personal information on air quality at your location, or some kind of a forecast. And they often also include information about allergy. So you can provide information if you are allergic to something, or how allergic you are. And then they kind of give you this assessment if it is safe to go outside or not. This example is from Latvia, where this kind of application have been done. But as I said, there is a lot of this type of application available for mobiles and also for online in the web. And the third environmental theme was regarding ozone monitoring and UV radiation. Here is example of monitoring of the ozone hole in 2020, which was one of the largest in recent years. The same has been done for the Arctic region. So there are web page dedicated for this ozone monitoring, and ozone is directly related to UV, or it modifies the amount of UV reaching the ground. So these two are therefore related. And just for our main interest in this Sentinel 5B data is in this UV and ozone monitoring. We have been measuring UV in Tartu Observatory for a while. Currently, the measurements have been stopped. And also, we have a cooperation with Finnish Meteorological Institute to validate this Sentinel 5B data, especially this UV data with ground measurements. And the second interest that is a new project that is shortly starting is to do with Arctic wildfires and the possibility of using this Copernicus data to assess and classify these different type of wildfires in the Arctic. And now I will shortly introduce what is coming for Copernicus regarding this atmospheric remote sensing. So in the middle of 2024, there is a plan to launch Sentinel 5. Sentinel 5 will not be a separate satellite, but will be an instrument on board of METOP satellite that is operated by EUMETSAT. The objective of Sentinel 5 will be very similar to Sentinel 5B, and also the the products that will be measured are very similar to Sentinel 5B. There are some differences, and actually just recently I found from the EUMETSAT page and WMO page that also CO2 will be included, but I'm not sure in this information, because in Copernicus information page this is not mentioned, but it will be very exciting if it's that is really true. Sentinel 5 will measure also with a 7-kilometer resolution for channels above 300 nanometers and 28 kilometers below 300 nanometers. And there are 2 more Sentinel 5s planned, one for 2031 and another one in 2038. And what is plus for Sentinel 5 is that actually on board of this METOP, there is a lot of other instruments, and this data can enhance the quality or the information that is received from Sentinel 5. Also in 2024, there is first geostationary air quality mission planned for Europe or for Copernicus. Again, it won't be a separate satellite, but it will be on board of Meteosat 3rd generation satellite. And it will cover most of the Europe. So the map in the middle shows the area that this mission will cover. And compared to Sentinel 5B and Sentinel 5, it will give data in every hour. So the measurement is in every hour. So we get much more information from the satellite. And the spatial resolution will be 8 times 8 kilometers. And all the products that are measured, again, are similar to Sentinel 5 and Sentinel 5B, with slight differences, and the objective of this satellite is similar. And Sentinel 4 will be part of this larger geostationary air quality constellation that involves also satellite over America and one over Asia. And also these polar orbiting satellites like Sentinel 5B and Sentinel 5 will also be included. So we get a really full coverage of air quality over the whole globe. So it will be a really full and detailed information that will soon be available. And the final mission that currently has been called out is this CO2M, or Copernicus Carbon Dioxide Monitoring Mission. And I think regarding this climate change, this is the most weighted mission. Right now, it is planned to be launched in 2025, and it will be a 2-satellite mission, so 2 satellites measuring at the same time. The main data product of this satellite will be, of course, CO2, like the name says, but then there will be also methane and NO2, and the resolution will be 4 square kilometers, so really fine resolution. And also aerosols and clouds will be measured with this instrument. And this data will be used to help track and implement the targets that were set with the Paris Agreement. So we could reach the goals set there. And it helps to detect and monitor the emitting hotspots and assess the emission changes against the local reduction targets, and also then assessing the national emissions and changes. So the goal would be that using this data, countries could report their CO2 emissions. The satellite itself doesn't really measure emissions, but the general concentration. But thanks to this data, it is possible to kind of calculate the emissions. So there will be actually 2 important events coming in just coming weeks that will possibly give a newer information. Maybe there has been quite many delays with, for example, with the launch of these satellites. Sentinel 5 was planned to be launched already this year. So next week there will be Living Planet Symposium, which has some presentations regarding these missions. And in the beginning of June, there will be CAM's General Assembly. This will be both on-site and online event. And there is still possibility to register for the online version of this General Assembly. I think it was even up to 6th of June that you can register and get the link to join in and hear the newest information regarding these data usage and these missions. So thank you very much. This is all from me.
I see that we currently don't have any questions yet in the comments, but I was curious about the Arctic wildfires. And as I understood, you use Sentinel 5B data to assess different types of fires. And I was wondering what kind of types of fires there are. And can this information be somehow used to prevent these fires?
Actually, this project is yet to be started. This will be in cooperation with Norwegian Space Agency. And the classification we were wondering is, first of all, it is assessing the fires that already have been. So if kind of the size of the fire or what is burning actually, is it forest fire? Is it peat fire? So we were wondering if adding information from Sentinel 5B would kind of give a better overview of these fires. I don't think it will help to prevent these fires, but it's kind of a just an extra information, because actually this Norwegian Space Agency, they are planning to develop this kind of a fire system or environment, and this classification might be just one layer on top of their development, if some reasonable results will be received.
Okay, very interesting. Thank you.